All right, ladies and gentlemen, welcome back to Unit Circle Notes. So I'm going to assume that you all have your unit circle filled in correctly at this point. If you don't, you need to make sure that you do have it filled in correctly. And so there's a couple last things that we're going to talk about. Let me go ahead and get rid of this down here so that I have room to work. All right, the very last thing that we have on this unit circle are these spots that say positive and negative. And what they're talking about is which trig functions are positive and which ones are negative in which quadrant. And so what we know is that we have right now 3 trig functions that we know. We have sine, cosine, and tangent. And so sine, cosine, tangent are always in reference to a certain angle in right triangles. So we've got sine theta, cosine theta, and tangent theta equals, right? So the ratio for sine theta is opposite over hypotenuse. The ratio for cosine is adjacent over hypotenuse. And the ratio for tangent is opposite over adjacent. So if we have a right triangle, for example, right, and here's the angle that I'm working with, theta, hypotenuse, right, is always on the side across from the right angle, so the hypotenuse will always be there. However, the opposite and the adjacent will switch depending on if I'm working with this angle or this angle. On the unit circle, we're always using this angle down here, so it makes things a little bit easier. So opposite will be over here, and then adjacent, meaning touching the angle, would be over here. All right, so if we apply that idea to any of these triangles in this quadrant, what we'll see is that our opposite, right, our opposite is our y value, and our adjacent right here is our x value, and our hypotenuse right here is always equal to 1, right? Which is also called the radius of the circle. So I'll say that again, right? That our sine of a theta will be opposite, which will be y, over the hypotenuse, which is 1, or r. Our cosine will be our x value over the hypotenuse, which is r, or x over 1, because our hypotenuse is 1. And tangent, theta, will be our opposite, which is y, over our adjacent, which is x. Okay, so what happens is if we look at these values, we can determine which quadrant each of those are, whoops, there we go, negative or positive. So first 1 is always positive, right? Or the radius is always positive. But y and x, they switch signs depending on which quadrant we're in. So in the first quadrant, both x and y are positive, positive. Therefore, all of these ratios will be positive and none of them would be negative. In the second quadrant, however, x is negative. So I'd cut that off, I'm sorry. In the first quadrant, x and y are both positive, positive and positive. So all of these ratios are going to be positive. Y is positive, x is positive, y is positive, x is positive, and 1 is, of course, always positive. In the second quadrant, however, x will be negative. And so x comma y will be negative comma positive. So any value over here that uses an x, or sorry, any function that uses an x over here will be negative. So we'll have sine being positive because it does not use x, so sine will be positive. But since cosine and tangent both have an x, cosine and tangent will be negative. In the third quadrant, both x and y are negative. And so in the third quadrant, this function will be negative, sine, because it uses a y. This function will be negative because it uses an x. But this function actually will be positive because you'll have a negative divided by a negative, which is a positive. And so tangent will be positive in this quadrant, but the other functions, sine and cosine, those would be negative. And then finally, in the last quadrant, quadrant 4, in this quadrant, x, y, well, x is positive, but y is negative. Whoops. Let me fix that. And so any function that uses y will be negative. So that means that sine and tangent will be negative, but cosine will be positive. So sine and tangent. And so there's a little saying to remember which functions are positive in which quadrant. All, S for sine, so all students, T, take, C, calculus. All students take calculus. It helps you remember which quadrant each one is positive or negative. All right, now that we've talked about which functions are positive in which quadrant, let's go ahead and do some practice finding sine, cosine, and tangent. Now, this is our big idea right here. So I'm going to write it at the top of the page. Recall, sine theta is y over 1 or r. Cosine theta is x over r, or x over 1. And tangent theta is y over x. Again, based off of opposite, adjacent, and hypotenuse. Okay, so you're going to use your unit circle to answer a few example questions. So find sine, cosine, and tangent of 3 pi over 4. So we're going to use our unit circle to do that. So I look at my unit circle and I find 3 pi over 4. So 3 pi over 4 is right here. It corresponds to this value right here. And so sine will be our y value over 1, which will be square root 2 over 2. So sine 3 pi over 4 is square root 2 over 2. And then cosine will be my x value, x over 1, which is negative square root 2 over 2. And then finally, tangent of 3 pi over 4 will be y over x, which will be this value over this value. So square root 2 over 2 over square root 2 over 2, but this one's negative. This is the same value, right? Square root 2 over 2 over square root 2 over 2, it's 1. Or you could multiply by the reciprocal to get rid of this fraction. So multiply by negative 2 over square root 2, and then these will reduce. And the negatives cancel. But if you do this to the denominator, you must do the same thing to the numerator. So I would multiply by negative 2 over square root 2. And these will reduce. Everything reduces to not 0. Remember, if we're reducing, it reduces to a 1. And it's negative because there's this negative. And then these are some that you can even check on your calculator if you're in radian mode. So we need to be in radian mode. So I'll go to radians. So let me change my mode. And if I do sine 3 pi over 4, I will get 0.7071, which if I simplify square root 2 over 2, I get the same answer. So I can verify that I'm correct. Tangent's a pretty cool one. We'll see that one easily. So tangent 3 pi over 4. We should get -1, and we do. So you can also verify that you've done it correctly using a calculator. All right, let's do another example. Let's find sine, cosine, tangent of -120 degrees. So recall, if it's -120, rather than moving this direction 120, we'll move backwards 120 degrees. Or you could just say, well, 360 minus 120 is 240 degrees. And so 240 degrees is right here on your unit circle. It's the same as 4 pi over 3. Here's our two values, -1/2 and -√3 over 2. There's x comma y. So sine is our y value, and they rhyme, sine and y, so you can remember that they sound the same, I should say. Sine and y go together, and then cosine and x go together. So cosine, sine, and tangent of -120 . Sine of -120 again is our y value, which is -√3 over 2. Again, we're just using the unit circle. Cosine of -120 is the x value, which is -1/2. And then tangent is where it gets difficult. Tangent of -120, we have y over x, so √3 over 2 and 1/2, they're both negative. And I'm going to use that same method I did before. I'm going to multiply both the top and bottom by the reciprocal of the denominator to get rid of the denominator. So these cancel, and so do your negatives. Here your negatives cancel and your 2's cancel, and you get √3 over 1, which is just √3. I think I went off of the camera. No, just a little bit. There we go. All right, we can do one more example. Let's do a special case, like, let's do find sine, cosine, tangent of pi over 2. Okay, so pi over 2 is right here on your unit circle. And so sine pi over 2, remember that's r. Sine is y over r, which is 1 over r, or 1 over 1. So sine pi over 2 is 1. And you can, again, verify this. I'm going to verify it on my calculator. So sine pi over 2, 1. All right, cosine pi over 2. Cosine pi over 2 is 0, our x value, right? Looking back at the unit circle. And tangent pi over 2 would be y over x, or sine over cosine. So that would be 1 over 0. You cannot have 0 in the denominator. This would be undefined. Undefined. And if you try on your calculator to find out what tangent of pi over 2 is, it will tell you error, domain error. You cannot do that. So if you get an error, it's because it is an undefined value. All right, guys, I'm going to give you some homework practice. I'll post that on Google Classroom along with these notes. If you have any questions, please let me know. Just meet me in a Zoom meeting. I'm available tomorrow at 10 o'clock. Bye-bye.